Okay, so we have this 199 default program, happens to have a piano sound. And what we're going to do is we're going to go inside of it, see some of the things that affect it, and edit it. Okay, so we have this 199 default program, happens to have a piano sound. And what we're going to do is we're going to go inside of it, see some of the things that affect it, and edit it. The way we do that is we go to the left of the screen here, and we hit this hard edit button. When we hit that, it comes up with this screen here that shows us all kinds of options for editing it. Notice this too, we have algorithm 1, and it says edit program alg. Okay, that means it does something. It's like processing type 1, or a combination of processing types. So I'm going to go up and I'm going to take my arrows until it's highlighted over there, and then I'm going to put it up to algorithm 2. Well, first let's hear algorithm 1. Just the regular piano sound we're used to hearing. If I hit plus, now look at this. All this other stuff comes up. Pitch, 2-pole, low pass, panner, amp. So something changed with algorithm 2. Now when we play, sounds kind of muted. You notice anything else about the pitch content? Hit plus again. Changes yet again. Sounds more like we heard it before. So I'm going to go through to different settings on there and listen to what they sound like. I'm going to hit a really high note. You don't even really hear it. Now I'm starting to hear it. Go down to the lowest part. I kind of hear those, but some parts of the sounds are different. So I've heard a lot of the different algorithms, and now I'm going to go back to the default one. Notice here it says pitch on the left side, none in the middle, and it has 3 arrows there, and then amp to the right of it, 1 arrow coming down there. Pitch only has 1 arrow too. So what we're going to do first is we're going to change things that have to do with the pitch. I'm going to take my arrow, I'm going to go over to pitch, and then again I'm going to hit this hard edit button. That brings us to the pitch editing screen, where we have all kinds of parameters we can use to change things about the pitch. Okay, so now we're going to edit some aspects of the pitch and see what it affects. This very far left one says coarse. It says, it looks like OST, it's actually 0 ST, 0 steps. So I'm going to hit a C, and there's my sound. Now when I hit the plus button, 1 step, hey, it shifted all the pitches on the piano up 1. So the coarse setting here changes everything. It shifts all the notes on the piano, or it transposes them all up or down if I hit the minus button. Next one down below, fine, it says 0 CT. Doesn't sound for 0 quart. Sounds for 0 cents. Okay, as you know from cents in a dollar, we have 100 cents to make a dollar. Cent for century or cents in a dollar has to do with 100. So when we're doing fine tuning, it divides the smallest pitch we have on the piano, okay, which is one of these spaces from any note to any next note. Here's C to C sharp / D flat. That's the smallest step I could possibly make. It could also be 2 white keys, so long as it's only 1 step from one key to the next. There's no keys in between. Okay, why did we talk about that? Because the fine setting of pitch allows us to adjust even smaller than what is on the piano, the smallest steps in the piano. In fact, it lets us take the pitch material for the smallest step and adjust it by 1/100th of the pitch distance. Let's see what that means then. I'm going to hit plus up to 50 or so. And what do you think is going to happen? Actually, it's hit 0 first and hear what it sounds like for reference. Now hit 50. 50 cent. Slightly higher. A quarter tone higher. Now each of these adjusts pitches the way we hear them according to the doubling of octaves. As you remember from earlier though, when we start out with the lowest A, which is about 30 hertz, 30 times per second, we go to the next octave, that's 60 hertz, twice as much. We only have 60 minus 30, or 30 hertz, between the first A and the next A. Not very much. By the time we get to the last notes, we're going from about 2,000 hertz to double 2,000, 4,000. So in that octave, we have 2,000 hertz difference. The first octave, about 30 hertz different. The last octave, about 2,000 hertz different. So the difference between each octave increases as we go up higher and higher, because we're always multiplying the last thing by 2. That's called an exponential curve. When we're adjusting by the coarse and fine tunings here, we're adjusting, transposing all the pitch material up and down according to notes in the scale. We're adjusting them according to exponential ways. If we go down below it even further to hertz, then we're going to adjust individual cycles of frequency. The 30 to 60 hertz or the 2,000 to 4,000. It's going to go then in a linear fashion. Okay, makes the same types of changes throughout in a line. Makes a linear rather than an exponential curve. So you can do really, really fine adjustments using this that wouldn't correspond to the way we hear octaves change over time. Tracking is different than the transposing. Tracking actually tells us about how much it moves up or down from key to key. Normally it sounds like this. That's the smallest step we can make. So I'll look down here. Here's my fingers going from that white key to that black key. It's the smallest step we can make on the piano. Well, what do you think would happen if we change the value for the tracking? I told you what a cent was. 100 cents is equal to one of those smallest steps on the piano. And by the way, those steps we call half steps. I hit 100, enter. So now I'm going to hit the same keys. What do you think will happen? So those of you in music classes recognize that as a whole tone scale. It makes it so each time you go up a note, it goes up twice as much as normal. It goes up 2 of those half steps instead of 1. If you played a normal scale, it won't sound like a normal scale anymore. Doesn't sound like your C scale, which normally sounds like this. It changes the amount by which the keyboard changes pitch. What do you think happens if we put it at minus 50 instead of 0? So we hit the minus button, 50, enter. By the way, minus button, we have this plus minus here, just hit it and it does minus for you. Okay, now we try it. I hit this C, hit the C sharp. Oh, doesn't sound like it changed as much. Now, if you noticed, the distance that's traveled is half that normal. Each time I go up a key, I go up another 100 cents, but now it's minus. What do you think will happen? Hit the C. Cool, sounds like normal. Next one.